Hi everyone, I want to quickly review the concept of multiplying matrices and the idea of a determinant of a square matrix. Okay, to begin with, we're going to take a look at multiplying matrices. The first thing you want to do when you have to multiply two matrices together is to name the dimensions. And to name dimensions of a matrix, you go rows by columns. So in this case, we have 2 rows and 3 columns. The second matrix, we have 3 rows and only 2 columns. And to be able to multiply two matrices together, the two middle numbers then must agree. The number of columns in matrix 1 must agree with the number of rows in the second matrix. And if those two numbers agree, then your answer is going to be the result of the outside number. So in our case here, we're going to be able to multiply our matrices together and get a 2 by 2 matrix. So there's going to be 4 entries that we need to be able to calculate. Okay, so 1, 2, 3, and 4. Okay, to find this first entry is located in the first row, first column. So I take a look at the numbers in the first row of the first matrix and the numbers in the first column of the second matrix. And the rule is you're going to be multiplying the corresponding numbers and taking the sum. So the sum of the product. So it sounds a lot harder than it really is. And if it helps, off to the side, you can always write down the row and underneath that put the corresponding values of the column. And they will always agree, they will always match up, because again, these numbers have to be the same. So what I'm going to do is I'm going to multiply. We get -2 plus 3 times -1 is -3 plus 0. This entry right here is -5. Okay, let me choose a different color and we'll find the entry that's in the first row second. So I'm going to use the first row of the first matrix and the second column. And I'm going to take -1 times 3 and I'm going to get -3. And then I'm going to take 3 times -2 and I'm going to get -6. And then finally 0 times 0 is 0. Add the numbers together and you get -9. Okay, you just have to keep yourself focused. It's not really that difficult to be able to multiply matrices. You just have to be careful of signs and keep yourself focused on the work. Okay, this guy right here is going to be located in the second row, first column. I'll circle the second row and circle the first column. And I'm going to take 4 times 2 and I'm going to get 8. And then I'm going to take -2 times -1 and get +2. And then finally 3 times 3 is 9. Add the numbers together, you're going to get 19. Okay, and finally, let's take another color. Let's use orange. Okay, so we have this row and this column. And we're going to get 4 times 3, which is 12. And then -2 times -2 is 4. And then finally 3 times 0 is 0. And we get 16. So here's our answer. Okay. Next, we're going to talk about how to find the determinant of a 2 by 2 matrix. And you have to know this right here to be able to find the number that's going to represent a square matrix. And in this case, we're going to first handle the 2 by 2 matrix. And it's relatively easy to do. You're going to take the product of the downward diagonal. So in this case, 2 times 4, you're going to get 8. And we're going to subtract the product of the upwards diagonal, which in this case, we get 1 times -3, which is -3. And so in this case, we're going to have 8 minus -3, which becomes 8 plus 3, which is 11. The determinant is 11. And knowing how to find the determinant, we're going to be able to do a lot of other concepts that involve matrices, like being able to find the inverse of a 2 by 2 matrix. Okay, so that's finding the determinant of a 2 by 2 matrix. Next, we're going to handle the determinant of a 3 by 3 matrix. And of course, this is going to be a little bit more involved. What you're going to need to do is repeat the first two columns of your 3 by 3 matrix. And basically, what you're going to do is take the sum of the product of the downward diagonals minus the sum of the products of the upward diagonals. And again, this sounds a lot more complicated than what it really is. So to begin, what we're going to do, for our example here, I'm going to repeat the first two columns. So 0, -3, 0, 4, 4, 1. And let's use the color red. So what I'm going to do is I'm going to circle all three downward diagonals. Okay, so again, we're going to take the product of each of these and then add everything together. So the sum of the products. So in this case, I multiply these three numbers together, I get 0. And then the next, we also get 0. It's always nice having 0 in our problem because it makes the calculations real easy. Here, we get -9. So when I add everything together, we get -9 for the sum of the products of my downward diagonals. The upward diagonals, I'll use a different color. We're going to do the same thing. This time we have the upwards diagonal that we need to multiply together. I have to make sure that looks like a -3. So in this case, we get 0 plus, again, we get 0 plus 3 times -3, -9 times 4, -36. Okay, so once we have this, what we're going to do is we have to write the -9 first, which was, again, the sum of the products of the downward diagonals, minus the sum of the products of the upward diagonals, which in our case, we got a -36. So when I do this calculation, -9 minus -36 is really -9 plus 36. You get a determinant of 27. And if you keep your work organized, you're easily going to be able to get these answers. And eventually, I'll show you how to use a calculator to find this answer. But determinants are important for some other areas that we're going to pursue when we're involving matrix operations. So again, this is the mechanics of how to find the determinant. If you have any questions, please ask and seek me out. Take care.